f of z naught by 2. Suppose I am choosing this epsilon. But first thing, is this epsilon positive? I already told you f of z naught is non-zero, correct? In the condition it is given that function is non-zero at z naught. Right here also f of z naught is non-zero. So I am choosing my epsilon as mod of f of z naught by 2. So if this is my epsilon, now let us write the definition. Correct? What is the definition? Mod of f of z minus f of z naught, that is less than mod of f of z naught by 2. This is the bracket and this is mod. Whenever, what is the condition? Whenever mod of z minus z naught is less than delta. So this is what I am having now. Okay. Now do you see some contradiction? If I assume this, then what I have to prove, that is function is zero, the function is non-zero throughout some neighborhood of this point, correct? Suppose in this neighborhood I am taking function as 0, then do you see some contradiction? Suppose in this neighborhood I am taking my function as 0, that means my f of z will be 0, then do you see some contradiction? If you this part will be 0, you will be remaining f of z naught, and that is less than equal to f of z naught by 2. Is that true? That is f of z naught is less than f of z naught by 2. That is definitely not true, correct? That means I just want to prove like this. So if there is a point z in neighborhood z minus z naught less than delta, at which function is 0, that is f of z equal to 0, then what we have, this will be 0, so we will be having f of z that is less than mod of f of z naught by 2, correct? Which is a contradiction, correct? Hence there does not exist any point z such that so that means in that neighborhood, hence the result is true, or hence this proves the theorem. Correct. Let us see once again what is the definition. Once I use the definition of function continuous, we are choosing epsilon as this one. Now you can choose epsilon mod f of z by 3, 4, कुछ भी choose किया. The thing is that what I want to claim, I want to claim this function. This function is non-zero throughout some neighborhood of the point. So this is a neighborhood I am having, correct? So let us use this one only. So suppose if I am having a point such that that function is 0 in this neighborhood, this is what I am assuming. If there is a point z in neighborhood z minus z naught that less than delta, at which function is 0, so I will be having a contradiction here, correct? What is my contradiction? Mod f of z that is less than f of z by 2, which is wrong, which is false, correct? That means your f of z naught must be, sorry, this is z naught, this is z naught, this part is 0, this will be minus f of z naught, which is same as f of z naught, mod theorem, no? So this is a contradiction, hence the theorem is proved. Yes, correct. Okay. One more thing, as you prove in the case of limit, I'll just write the statement. I'm not going to prove because हम लोगों ने limit में proof किया है, तो you just have to replace something. Yeah, the function is continuous function f of z. I say function f of z. Say f of z is continuous at a point z naught equal to x naught y naught if and only if its component function are continuous there, correct? What do you mean by that? That means अगर function को मैंने that means right, if I write f of z equal to u of x comma y plus I times v of x comma y is continuous at z equal to z naught if and only if u of x comma y and v of x comma y are continuous at correct. And what is your z naught? You should say where z naught is. I'll write like this. X naught y naught. You should understand it is a complex number. Huh? I'm just writing it then that form. Correct. U and V are continuous at this point. Correct. So the proof is similar to your proof of limit. Correct. In this case, the limit of you are aware with the limit. Limit will be your f of z naught. So answer will be u of x naught y naught plus I of v of x naught y naught. Correct. Yes. And one more thing, if your function is continuous in that neighborhood, then it will be bounded. Do you agree? Function will be bounded also in that neighborhood. That means if I write it, that is, if a function f is continuous throughout a region R that is both closed and bounded. Closed and bounded is also called as compact. I think compact शायद मैम ने start किया है. So once you see closed and bounded space, that is compact space. There exists a non-negative real number and such that mod of f of z that is bounded, that means that is less than equal to m for all z in that region R. If your function is continuous in that region R where R is closed and bounded region, then that function will be bounded in that. And one equality holds where equality holds for at least one such z. Yes. Okay, how will you prove this? Yes, how will you prove this? See, I'll just give you a hint. Just try to see. You are given f equal to u plus iv is continuous, correct? Yes. So if u plus iv is continuous, that means u and v are continuous, correct? As per the theorem, that means their component should be continuous. And if u and v are continuous, what about this square root of u square plus v square? That means I'm taking mod of that function. Square root of u square plus v square, that is also continuous. Correct? Now if my function, that is square root of u square plus v square, is continuous, which is a real valued function in a closed and bounded interval. So do you remember a theorem? What is that called? Uh, if your function is continuous and closed and bounded, then it attains its bound. That means it will have a maximum and it will have a minimum. Continuous on R, sorry, on R, where R is your closed and bounded. So as per your semester 3 theorem, that means if your function is continuous on closed and bounded region, then it will attains a bound. That means what? Then I can say this thing, that is this thing is same as mod f of z. Do you agree? This thing is same as mod f of z attains its bound. That means what? That should be less than m, less than equal to m. There should exist a m such that this is true. Yes. You just have to write it properly. That's it. Otherwise, proof is quite easy. Here again, function u plus iv is continuous. So u and v both are continuous. So what about this square root of u square plus v square? That is also continuous because it is just algebra of continuous function. And this is continuous on R. Now what is this thing? U and v were in terms of x and y. There is no complex term here. So this is in R2 you can consider. And it is continuous and closed and bounded region. That means what? If it's continuous on a closed and bounded interval, that means it will attain its bound actually. Extreme value theorem, something the name of the theorem is. Yes. Okay. Now, okay, let us do one exercise. Yeah. The question is T of Z is equal to Ez plus B upon Cz plus D. This is a famous thing. Later on, you will see this is called Mobius transformation. We'll define it. That is also called bilinear transformation. This is in third unit. So prove this. If limit, that is limit z tending to infinity, t of z is infinity if c is 0, and b limit z tending to infinity, t of z is equal to e by c, and limit z tending to minus d by c, t of z, that is infinity if c is not 0. First of all, do you see the proof? They are quite simple. By using L'Hopital rule, you can do that. If you take the first one, that is z tending to infinity f of z, and you are given c as a 0. So if my c is 0, then there is no point of doing L'Hopital rule. It will be directly in terms of z. So you can directly substitute. So if you directly substitute, that will be infinity. And what about the second one, b? That I already told you. You just apply L'Hopital rule. Since it is infinity by infinity, derivative will be a, and here it will be c. So answer is a by c. Correct. Now, if my limit is z tending to minus d by c, correct. So put it in the numerator. It is having no issue, and Actually z equal to z tending to minus d by c is a root of this, correct? So once this is a root, and there is no point of cutting both the thing because both are in the linear term, and a b और ये सब same नहीं है. So that means z must converge to minus d by that means that must go to infinity because denominator में zero होगा, that will be infinity. Yes. Okay. I'll write just exercise. Yeah. Hmm. Now let us go to the next term. These all things are we are just taking a revision. Next thing is derivatives. Okay. Can you define the definition of derivatives? First of all, 12th standard definition. Do you remember that? क्या था वो? What was the name? First principle, I think. Do you remember that definition? Something f dash of z not that was same as anybody. Come on, quickly tell me. Limit. Yes, this was your first principle. Okay, perfect, very nice, good. So this was actually this was of your BSc. Now I want 12th standard or definition. 12th standard or first principle. So once I talk about first principle, डिनोमिनेटर में h था एंड ऐसा कुछ, दैट मीन्स दे वर नॉट अवेयर कि वो जो पहले तूने बताया ना, मुझे इतना नहीं पता था. सो आई विल जस्ट राइट h को मैं डेल्टा z लिखता हूँ मैं. सो आई एम राइटिंग डेल्टा z टेन टू ज़ीरो. सो दिस इज z नॉट प्लस डेल्टा z and this is z naught divided by delta z. So h is just replaced by delta z, that's it, everybody is same, correct? And actually the original definition is this one, f dash of z naught that is equal to limit z tending to z naught f of z minus f of z naught upon z minus z naught, correct? And do you agree both are same, both are equivalent actually, both the definition are equivalent, either you use this one or this one. Do you agree? It is just one substitution from here to here, or from here to here, whatever you say. From here to here, if you want to come, then at the place of z naught plus delta z, you have to put z. That means what? Put z equal to z naught plus delta z. That's it. Everything will be okay. That means in our case, uh, what is that? X equal to e plus h. X equal to e plus h if I am talking about in the real cases. Correct? So this is the definition of derivatives. But this is definition of derivative in terms of limit. Now next question is, can you give the definition of derivatives in terms of epsilon delta? And that is quite easy because we are having that limit. Limit का तुमको पता है कैसे लिखने का, correct? Can you tell me quickly? Can you tell me definition of derivative in terms of epsilon delta? Yes. Since it is again limit only, na? So you will use the definition of limit. So what is definition of limit? For all epsilon positive, correct? What is the condition? There exists delta positive such that mod of z minus z naught, that is less than delta. Again bracket open. What is the condition? Condition is f of z minus f of z naught upon z minus z naught minus f dash of z naught, that is less than epsilon. Correct. Bracket open, close, 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 जितनी बार भी हो, something like this. Correct. Or if you want in terms of Burton, then it will be for all epsilon positive, there exists delta positive satisfying mod of z minus z naught less than delta, imply mod of f of z minus f of z naught upon z minus z naught minus f dash of z naught, that is less than epsilon. Correct. Yes. Okay, nice. Let us do some example. F of z equal to z square. So how do you do that? If you want to use a derivative, if you want to find derivative, that means f dash of, say, f dash of z. So what is the formula? Suppose if I am applying your first principle, so what is the rule? Limit delta z tending to, yes, bolo, h tending to 0 na, and this will be f of z plus z naught minus f of z. Sorry, actually it should be z plus delta z. Should not be delta z naught, it should be delta z. Z plus delta z minus f of z upon delta z. So you just need to substitute. क्या आएगा ये? Limit delta z tending to 0. What is f z plus delta z? So it is z plus delta z the whole square minus z square divided by delta z. Correct? And you can clearly see what is the answer. Yes. In the second term it will have delta z, and the yeah, in the second it will go away. So answer will be 2z. Do you agree? And as I told you, it works as x raised to n. So answer will be 2x. This was easy since my function was in this term. It was in terms of z only. Okay. So answer is 2z. Let me ask one more question. That means if f of z equal to z bar, then can you do that again? If it is z bar, check whether it is continuous or not. Sorry, check whether it is differentiable or not. Yes, again, how will you do that? What is the idea? That is f dash of z, that is equal to limit delta z tending to 0, f of z plus delta z minus f of z upon, it is delta z. Correct? So what is that? Limit delta z tending to 0. What is z plus delta z? So it will be z plus delta z bar minus f of z, that is z bar. Correct? Upon delta z. What is that? Limit delta z tending to 0. Mod of z plus z bar is same as z bar plus delta z bar minus z bar upon delta z. Okay, what is the value? Limit delta z tending to 0. What is this thing? Delta z bar upon delta z. Oh wow. Have you done something like this? Yes, have you done something like this? Or if you don't like, then that delta z, no, delta z को put कर दो something, x plus, yeah, x naught y naught whatever you want, or ab. And have you proved something? If you remember, in limits हम लोग ने एक example लिया था. Do you remember that?